And all right, so going from u substitution, the idea behind this is that we have a function, and whatever f of u is, du is equal to f of x plus some constant. All right. Now, I said this before in some individual groups, and it's important to know this about your book because it can get a little bit weird. In your book, and I'm trying to use the same notation that they are using. So whenever your book uses the lowercase of the function, it means the same thing as the derivative of the capital F of the function. So let's say we go ahead and have the integral of x squared minus 9 to the third power times 2x dx. So if I label u as x squared minus 9, then the derivative of u is equal to 2x. Now, what's the other way I can go ahead and write the notation for the derivative of u? I can say that is du over dx. That's the other notation. Think back, that would be the same thing as if I had either y prime, or I could also use dy dx. So now that is equal to 2x, so du is equal to 2x dx. So what I have all inside here, all of this inside the parentheses is u. And then all of this on the outside over here is du. So integration is just the antiderivative of something. So anytime that you would have had to use the chain rule, you have to use u substitution. So now if I can come over down and rewrite this, then I get the integral of u to the third du. Now I can just go ahead and integrate that, and that becomes u to the fourth over 4 plus some constant. And then when I substitute it back in, it just becomes x squared minus 9 to the fourth power all over 4 plus some constant. All right, so I want to go ahead and integrate this. So before I do that, I want to give you a second. What would u be? What is the derivative of u? And then how would you rewrite the integral? In terms of u. All right, so go ahead, take a second, try that. All right, so we are going to use the inside portion, this piece here, for u. So that's going to be x to the fourth plus 5. So the derivative of that is just 4x to the third. Now, we want to go ahead and write this as du over dx. We want this notation. Remember, that is going to equal 4x to the third, or that now du is equal to 4x to the third dx. So to write this in terms of u, I just want to make sure I have everything I need here. This just becomes the integral of u to the 1/2 du. I integrate that. That gives me u to the 1/2 plus 1 all over 1/2 plus 1 is 3. Oops, I wrote 3/3. It's not 3/3, it's 3/2. Plus my constant, which gives me, whenever you have a complex fraction in the denominator, this just goes ahead and comes up. So then that just gives me 2 u to the 3/2 all over 3 plus my constant. And then at the very end, substitute u back in. So then I just have 2 times x to the 4th plus 5 to the 3/2 all over 3 plus my constant. So the question was, again, where did the 1/2 come from? So I just take, if I have the square root of u, that's the same thing as saying u to the 1/2 power. One of the properties of integrals, if you have the integral of c, any constant, times u du, I can go ahead and always pull that constant out in front of the integration, right? That's not going to be a problem. And one of the things, and one of the little tricks that we're going to go ahead and use here is this idea, because in the last example, everything matched up, but all of the examples don't always work like that. So if I give you the integral of x squared times 3 minus 10x to the 3rd to the 4th power dx, I'm going to have to play with that constant. All right, so again, I'm going to let the inside portion of this equal u. The derivative of u is just going to be negative 10 times 3x squared. Instead of writing it as u prime like this, I'm going to write it as du over dx. Those two things mean the same. So that is equal to negative 30x squared. And then we need to solve for du. So du is equal to negative 30x squared dx. And it's really important that we talk about the notation for this, because when we're doing these and taking the integration of something, whatever variable you have, if your variable is x, the dx must absolutely match. So if we're going to change this to terms of u, if you're going to have u as your variable, you must also have du inside there. They must match up, otherwise you can't go ahead and do that, at least right now, at least. There's other ways, but that's for another class. I'm looking at this. Du is negative 30x squared dx. I don't have that negative 30. Now, like I said, if you can see how to do this in one step and just go directly to the u substitution, fine. But what I want to show you how to do is doing this one step at a time. So what we want to go ahead and do here is you want to solve this for solve for dx. So if I do that, then dx is equal to du over negative 30x squared. Now I can go ahead and replace it. I take whatever I have that dx is, which is this, and I want to go up and replace it with dx. When I do that, that gives me the integral from x squared. I'm going to go ahead and change this to u because we've already said that's what I want u to be. I want u to be everything that is inside those parentheses. And u is to the fourth power. You don't have to put parentheses in it. Sorry about that. And then I'm replacing this with dx. So instead of writing dx, I am writing that it is du over negative 30 x squared. Now these x squareds cancel out. I can bring that 1 over negative 30 out front. And then I just have the integral of u to the fourth du. All right, so all we did here is we just solved for dx and substituted it in. Now I'm going to go ahead and just find the integral of this. I'm just going to make this a little bit smaller so it all fits on one slide. I'm assuming you can all still see it. So that just gives me now the 1 over negative 30 stays out front. Then I get to multiply this times u to the 5th over 5 plus my constant. And then I substitute u back in and multiply those two together. So I have 3 minus 10x to the third to the 5th power plus my constant. And that is all over 150. And I do need a negative sign out there. So let's just stick the negative right there.